For introduction, nuclear reactors are machines in power plant that regulate and contain nuclear chain reactions, releasing heat at a controlled rate. A nuclear reactor converts water into steam, which is then powered by turbine generators, generating electricity. Nuclear reactors are commonly utilized for base load due to lower cost, but construction can be costly, potentially requiring significant financial investments over 5 to 10 years. Nuclear energy currently supplies 10% of the world's electricity through approximately 440 power reactors. Here are a few objectives in our research. The first one is to investigate the importance of nuclear reactor in power plant for human and environment. We also need to identify what is the potential carriers and skills needed related to nuclear reactor. To collect information about recent study of nuclear reactor, to know the applicability of nuclear reactor in daily life, to learn the significance of continuous self-development, to know what the challenges and what strategies for overcoming the problem. Here are a few methodologies that can be found through various sources such as scientific journals, academic publications, government reports, industry websites, and reputable online database. Why we choose nuclear power plant and its relevance to modern physics. There are a few reasons. Here's why. The first is energy generation. The second one is physics principles. The third one is cutting edge research. Continuing with the fourth one, environmental impact. And the fifth one is technological innovation. These are the reasons that we used to research about the nuclear power plant and its relevance to modern physics.
So next we can go to the importance of nuclear reactor in power plant. So for the human, firstly it's great job. Nuclear power plant construction, operation and maintain generate the numerous job that including specialized engineer and support staff. So for the second is economic stability. Nuclear energy stable, the electricity price can protect economies from the fluctuating nature of fossil fuel market. So for the thirdly is a technological innovation, ensuring the safety of different sector and technology is made possible by the measure that can advancement in material science and safety regulation. For the importance of nuclear reactor in power plant for environment is firstly is low greenhouse gas emission. They produce minimal greenhouse gas that helping the combat climate change. Secondly, is biodiversity preservation is a smallest footprint and reduce resources extraction means less disruption to wildlife and ecosystem. Thirdly, is manage waste effectively. Throughout the produce radioactive is waste, it is managed carefully to the minimize environmental impact.
Example of real-world nuclear reactor. First, we have Vladimir Lenin Nuclear Power Plant. It's located at Chernobyl Nuclear Power Plant near Pripyat, Kiev Oblast, Ukraine. It had four active RBMK reactors, and on 2015, they added two more reactors. On 1986, reactor number 4 exploded and suffered a catastrophic explosion and meltdown, making the worst nuclear disaster in history. The reactor went out of control during the during a test at low power, leading to an explosion and fire that demolished the reactor building and released a large amount of radiation into the atmosphere. Next, we have Kashiwazaki Kariwa Nuclear Power Plant. It located at Niigata Prefecture, Japan. The plant has five BWR-5 reactors and two advanced boiling water reactors (ABWR). The the Kashiwa the Kashiwazaki Kariwa nuclear power plants play a crucial role in Japan's energy mix, providing a substantial portion of the country's electricity and helping to reduce greenhouse gas emissions by offering a stable and low-carbon source of energy.
For applicability, we have four main points. First, how does nuclear reactor work? Nuclear reactor work using the heat energy released from splitting atoms of certain elements to generate electricity. A continuous fission of few atoms release energy harnessed as heat in gas or water to produce steam which drives turbine for electricity generation. Second is component of a reactor nuclear. First, fuel. Usually pellets of uranium oxide used as basic fuel, but a new reactor usually use beryllium mixed with polonium, radium, or other alpha emitter. Also, we have moderator that it is usually water, but may be heavy water or graphite. Next, control rods or blades, coolant, pressure vessel, steam generator, and containment. Third is fueling a nuclear reactor. Reactors are typically shut down for refueling to enable the vessel to open up. Refueling occurs at intervals of 12, 18, or 24 months. A power reactor can operate on natural uranium instead of enriched uranium using a graphite or heavy water as a moderator. And fourth is main type of nuclear reactor. First, pressurized water reactor, boiling water reactor, pressurized heavy water reactor, advanced gas cooled reactor like water graphite moderated reactor, and fast neutron reactor.
A recent study on nuclear reactors in power plants has highlighted advancement in safety, efficiency, and sustainability. The research emphasized the development of next-generation reactors such as Small Modular Reactor (SMR) and Generation 4 reactor, which promise enhanced safety features and lower risk of accident. These reactors are designed to be more efficient in fuel usage, producing less nuclear waste and utilizing closed fuel cycles. The study also exposed the integration of renewable energy sources with nuclear power, aiming to create a more resilient and low-carbon energy grid. The finding underscored the potential of modern nuclear technology to play a crucial role in the transition to a sustainable and reliable energy future.
Potential career in nuclear reactor in power plant. First is nuclear technician is a typically work in nuclear energy production or as physicist, engineer and other professional in nuclear research. Secondly is field service engineer is responsible for the maintenance, installation and repair of a wide variety of machinery system and equipment. Thirdly is a nuclear power reactor operator is a accordance with policies and procedure to protect workers from radiation and to ensure the environmental safety. So for the last one is a chemist. Chemist is a investigate the nuclear processes and develop radioactive medicine for medical and imaging uses.
Specific skill needed: technical proficiency in nuclear engineering, a deep understanding of nuclear physics, reactor dynamics, and the principle of nuclear fusion is essential. This includes knowledge of reactor design, operation and maintenance, safety and regulatory compliance, knowledge of the strict safety protocols and regulatory requirements governing nuclear facilities is critical. This includes understanding and implementing safety procedures to protect workers, the public, and the environment from radiation hazard. Next, continuous learning. The ability to diagnose and solve complex problems is crucial in a nuclear reactor environment. This involves analyzing data, identifying potential issues, and implementing effective solutions promptly. And lastly, teamwork and communication. The operation of nuclear reactor involves various specialized roles, including engineering, technicians, safety officer, and regulatory compliance experts. Effective teamwork ensures that all these roles work cohesively to maintain reactor safety, efficiency, and reliability.
Now we move to significance of continuous self-development. We have 5 points here. First, technology advancement. New technologies can be utilized by professionals to enhance efficiency, safety, and reduce environmental impact. Second is career advancement. This opens door to leadership positions, specialized positions, and research and development opportunities. Third is adaptability. This program provides individuals with necessary skills and resilience to excel in a dynamic field like nuclear energy. Fourth is operational efficiency. This tool allows professionals to apply best practices and develop innovation solutions. And the last is regulatory changes. Continuous learning is crucial for professionals to stay updated on changes, ensuring compliance and maintaining safety in operations.
Next is challenge for this career. The first one is safety concerns. Nuclear reactor demand strict safety protocols due to the risk of radioactive materials. Second is complex technology. Understanding nuclear physics and intricate system is essential. Uh, Third is regulatory compliance. Adhering to stringent regulation is crucial for operational legality. The last one is emergency preparedness. Being ready for emergency is vital, requiring rigorous training. In summary, nuclear reactors are sophisticated systems that play a crucial role in the production of reliable and large-scale electricity. By harnessing the energy from nuclear fission, we can generate significant amounts of power while maintaining a low carbon footprint, which is essential in the fight against climate change. So for the reference, we include 6 links that we got from Wikipedia, library, and also some resources on Google, such as like nuclear power in the world today, also the advantages and challenges of nuclear energy. So that's all from our group. Thank you.